The aim of the experiment was to determine the temporary and the permanent hardness of tap water by titration with EDTA. We used the following materials and chemicals in this experiment. Firstly, we boiled 1 liter of water for the entire class in a kettle and let it cool down to 35 degrees Celsius. Both samples are titrated at the same temperature because it makes it easier to see the difference in results. When the difference is clear, it's also easier to compare the two. A burette was filled with EDTA solution so we could then adjust to 0. Then we measured 50 milliliters of tap water by using a volumetric cylinder and then transferred it into a conical flask. 2 milliliters of buffer with the pH of 10 was then added. Afterwards, the conical flask was put on a magnetic stirrer with heater so we could add a magnet and warm it carefully to 35 degrees Celsius. A spatula of the indicator Erichrome black tea was added and the solution turned pink. Titration with EDTA was next. The process of this took a while because the EDTA should be dropped slowly and carefully and be watched at all times during the experiment to notice a color change. When the solution turned blue, drop by drop the volume was noted. The entire procedure was then repeated with boiling water. The solution with tap water turned into a light pink solution and drop by drop it turned into a more lavender color. The solution turned completely blue after using 18.8 milliliters of EDTA, which was measured on the burette. We now had the volume of EDTA 4-. During the titration, this chemical reaction happens. The calcium ions bond with the EDTA in the solution, and so does the magnesium. The indicator bonds with both calcium and magnesium, and then EDTA is added to the solution and takes away the calcium and magnesium from the indicator until there's no one left in the solution. EDTA is therefore an ion that wants to bond with metal ions. The indicator Erichrome black tea starts off being bonded to calcium and magnesium, and then it is stolen by EDTA. The purple or pink color occurs when the indicator is bonded to the metal ions. The color change occurs when the indicator is no longer bonded with these metal ions. So, firstly I will do and explain the calculations using tap water. The volume of EDTA 4- was measured to be 18.8 milliliters, which is the same as 0.0188 liters. The concentration of EDTA is 0.010 moles per liter, which is the same as 0.010 molar. The amount of EDTA was calculated by multiplying C and V, which was 0.010 molar times 0.0188 liters, which equals 0.000188 mole. The amount of calcium plus magnesium equals the amount of EDTA, so the ratio is 1:1. The hardness is determined by looking at how much calcium oxide the water contains, as we see right here. The molar mass of calcium oxide was calculated by taking the weight of calcium and add the weight of oxygen. That gave 56.077 grams per mole. Now we can calculate the mass of calcium oxide by multiplying the amount of the molar mass, which looks like this: 0.000188 mole times 56.077 grams per mole, which equals 0.0105 grams equals 10.5 milligrams, which is shown right here. The mass of calcium oxide in 1 liter was now calculated by dividing 1000 milliliters with 50 milliliters, and then multiplying with 10.5, which equals 210 milligrams calcium oxide per liter. The water hardness was then figured out by dividing the mass of calcium oxide in 1 liter with 10 milligrams calcium oxide per liter per degrees hardness. The water hardness in tap water was 21 degrees hardness, shown here. The result of the calculations was 21 degrees hardness, and if we look at this map, we are in the northern Zealand, which is a turquoise color, and this picture says that the water hardness should be around 12 to 18, so our result is a bit high compared to this. The volume of EDTA was measured to be 17.4 milliliters, which is the same as 0.0174 liters. The amount of EDTA was calculated by multiplying C and V, which was 0.010 molar times 0.0174 liters, which equals 0.000174 mole. The amount of calcium plus magnesium equals the amount of EDTA, so the ratio is 1:1. The hardness is determined by looking at how much calcium oxide the water contains, as we see right here. The molar mass of calcium oxide was calculated by taking the weight of calcium and adding to the weight of oxygen. That gave 56.077 grams per mole. Now we can calculate the mass of calcium oxide by multiplying the amount and the molar mass, which looks like this: 0.000174 mole times 56.077 grams per mole, which equals 0.0098 grams, which is the same as 9.8 milligrams, shown right here. The mass of calcium oxide in 1 liter was now calculated by dividing 1,000 milliliters with 50 milliliters, and then multiplying with 9.8, which equals 196 milligrams calcium oxide per liter. The water hardness was then figured out by dividing the mass of calcium oxide in 1 liter with 10 milligrams calcium oxide per liter per degrees hardness. The water hardness in boiled tap water was 19.6 degrees hardness. The temporary hardness is the difference in hardness between the tap water and the boiled tap water. The permanent hardness is the result of the experiment with boiled tap water. So to calculate the temporary hardness, we must find the difference by minusing the hardness of tap water with the hardness of boiled tap water, which equals 1.4 degrees hardness. It is 21 degrees hardness minus 19.6 degrees hardness. The result of the boiled tap water experiment was 19.6 degrees hardness. If we compare to this picture again, it must be around 12 to 18 degrees hardness, and we are still in the turquoise area, so our result is still a bit high. There is a clear difference in the two results. The tap water solution contained from the beginning of the experiment more calcium ions than from the beginning of the boiled tap water experiment. During the boiling of the tap water, some of the calcium ions was evaporated because of the heat and also left some in the kettle. The results are therefore different because the boiled solution had less calcium ions to bond with either the indicator or EDTA. The tap water result was 21 degrees hardness, and if we compare to the hardness of the water in our area, which is the light blue or turquoise color, then the result is a bit higher than it should be. The boiled tap water result was 19.6 degrees hardness, and if we also compare this to the hardness in our area, this result is also a bit higher than it should be by looking at this picture. The water should be around 12 to 18 degrees hardness. The reason water contains so many calcium ions is because the water in Denmark is taken from the subsoil water. The soil contains these metals, and it is brought up with the water. Some areas contain more calcium than others. These areas with very hard water has a large amount of calcium ions and other metals in the soil. An assumption that the degrees hardness in Denmark are 1 is made and proven must be this: 10 milligrams per liter of calcium oxide is the same as 0.0 grams per liter of calcium oxide. Now to calculate the amount of calcium oxide per liter using this formula. N equals little m over large M is the amount of calcium oxide, which is shown right here. Then it's little m of the mass of calcium oxide over the molar mass of calcium oxide, which is the numbers just put in right here, which equals 0.000178 moles per liter. Now to separate calcium oxide and find the concentration of calcium, which also is the concentration of magnesium, because the ratio is 1:1, we must divide with 2 right here, and that equals 0.00008915 molar. The concentration of the two is now added to prove the assumption. The two results right here is put in, and that equals 0.000178 molar, which is the same as 1.78 times 10 in minus 4 molar. The results correspond with the assumption. By looking at this map again, we see there is a very different hardness in the water around in Denmark. The very soft water is found in the middle of Jutland, and the very hard water is found mainly in Zealand. Hard water is found in the southern of Zealand, but the extremely hard water is found around Copenhagen in the pink areas. The different soil and what we do to the soil has a large impact on the water hardness. The water we use to wash our clothes with the same water as we drink. To avoid the metals like calcium and magnesium to hang onto the clothes and leave it precipitate inside the washing machine, EDTA is added to the detergent. The harder the water is in the area, the more detergent is needed for the EDTA to bond with the metals so the precipitate is avoided.